let's understand what are the different factors on which the heating effect of our electric current depends. Now, first of all, the most important factor is our material, or basically we can say that resistance. This we have already discussed in our previous slides also. So what is resistance? Resistance is the ability of the material to obstruct the pathway of charges. That is, to obstruct the flow of charges is resistance. Now, higher will be the resistance, higher will be the heating effect of that element. Now, here what we are going to do is, how we are going to understand this resistance is by taking two type of wires. Now, what you need to do is connect these two type of wires, like first one is nichrome wire into your circuit and other one is your copper wire. Now, in this case, when you'll switch on the circuits, right, like we have done in our previous activity also, like how we have made the connection of nichrome wire and copper wire. Now, the same thing you are going to do here also, make that connections. And again, in the case of nichrome wire, what you'll see is, in the case of nichrome wire, the wire will become hot after some time as it has higher resistance, right? And because of higher resistance, what will happen? Because of higher resistance, what will happen? The electrical energy which was present or which is passing into the circuit converts into heat energy. Why? Just because the nichrome has higher resistance, or we can say that it obstructs the pathway of the charges. But in the case of copper wire, it doesn't have higher resistance, and when it is connected into the circuit, what will happen? There will be a proper flow, and as a result, what will happen? The electrical energy is not converted into our heat energy. So because of this, only the materials which provide us the heating effect or which have the higher resistance are used for the heating effect of electric current in the devices like electrical heaters or our bulbs, or we can say that in our geysers. In that case, these type of materials are used which has higher resistance. But the materials which have low resistance, they are not used at all in these type of appliances, because the material which has higher resistance only, they only can convert the electrical energy into heat energy. Why? Because they obstruct the pathway of charges, or they doesn't allow the charges to flow so easily from them. And because of that, the charges will stay in that material for longer time, and as a result, the electricity is easily converted into heat and we'll get our heating effect. But the appliances which doesn't have the higher resistance, what happens? They don't obstruct the pathway and charges flow through them easily. And as a result, as the charges are not stopping there or are not obstructing into the material, they easily go out and no conversion of electrical energy into heat energy take place. So that is how the our resistance of the material is so much important for the heating effect of current. So that is about resistance. Now let's move to a second factor, that is length. Now, how the length of the material defines the heating effect, or how the heating effect is affected by the length. Now see here, if there are two wires, one wire is of smaller length and that is our wire 1, and one wire which is of longer length. Now in this case, what will happen? The one which has the less length, in this case, what will happen? The charges which were present in this, they can easily flow and they take less time to flow. And in this case, what will happen? The electrical energy though convert into heat energy, but not that much, because the charges are not staying in the material, not staying in the wire for longer time. So they can easily they are easily flowing and taking less time to getting out of the wire. But in the second case, which is our wire 2, and in this case, what is that? The length is little bit longer, and as a result, what happens? The charges which are present here will stay in the wire or take more time to cover the length of this wire, and hence these charges, or we can say that the electricity will be converted into heat, and as a result the material or the wire which have longer length will provide more heat energy as compared to the one which has less length or smaller in length. So that is how length affects the heating effect of electric current. Now third factor is thickness. So thickness here basically, so this is about the length. Now thickness here basically we can say that is the area. Again, here also we are going to understand by two cases. In case 1, we are going to take a material which has less thickness, right? The area of cross section from where the charges need to pass is less, right? Now the case 2, here we can say that the area of cross section is more, or we can say that the charges have more area to cover. Now here what will happen, we know that how the charges flow, they just bounce back from क्या होता है कि वो एक दूसरे से टकराते हैं and then only they flow. But here what will happen, the wire in which there is more area. In first case where is less area, the charges can easily go cover the area and go out from the wire, and as a result they are staying in the wire for less time and there will be no proper conversion of electrical energy into heat energy. But in the case where we have a more area, or we can say that the wire is more thick, there what the charges need to do is they need to cover the distance, more area in less time, and as a result what will happen, they'll here take more time to cover this distance and stay in the wire for longer time, and then easily the charges or electrical charges can be easily converted into heat energy, and then in that case again the material which has more area will provide more resistance, and as a result this kind of material which has more area can give us more heating effect. So these are the different factors on which our heating effect depends, and if I want good kind of electrical device which provide more heat, I have to be very careful with these three factors. Then only my appliances work properly. Otherwise, there will be no proper functioning of the appliances. So here are some examples of electrical appliances that works on the principle of heating effect of electric current. These are geyser, iron, electric heaters, electric stoves. So here, what are the material that is used to make this appliances is of higher resistance, so that there will be a proper conversion of electrical energy into heat energy, and hence the heat is provided in some form so that we can get some advantage from these appliances. Like in the case of geysers, the material which is present inside the geyser becomes hot when, or we can say that converts the electrical energy into heat energy, and as a result what happens, the water inside the geyser becomes hot. In the case of iron, the material which is used towards the downward to iron our clothes is again of higher resistance, and there also it do the same function, that is it converts the electrical energy into heat energy. In the case of electrical heater and electrical stove, what happens, the material that is used here becomes so hot that it becomes red, and as a result the heat is emitted from them towards outward, and then this heat can be used for different purposes. Like in the case of electrical heater, we know that we use that for warming our room temperature during the winters, and in case of electrical stoves, what we do, we use that heat for the cooking purposes. So that is how the different appliances are made on the working principle of heating effect of electric current.